Okay, so I want to go over some more things that affect enzymes. And there are several things that affect enzymes, but let's start with some of the more fundamental ones. pH, or the concentration of H+. You see here a nice chart that lists on the x-axis the pH of a given solution. Note that your body can have different pHs at different times, and you can have the reaction rate increase on the y-axis. What this means is that there are different reaction rates that can take place at different pH ranges for a given enzyme. Every enzyme is different. This particular enzyme shows its highest reaction rate at about a pH of 6. So imagine that this is in a part of the body with a lower pH, and this enzyme gets transferred to something with a higher pH. It will still work, just not as well. Eventually it will stop working, maybe, depends on the enzyme, but there is a narrow range that is really the best range for each enzyme. In the same way, there's a narrow temperature that most enzymes work best at. So if you have a given temperature, the highest rate that it can react would be, defined at this line for this particular enzyme, but you have to be careful with temperature. So there's a reason why your body tends to get higher temperature when you're infected with something. Because most enzymes, when you get them a high enough temperature, the protein portion of that enzyme just unfolds and it no longer works, because that's when the enzyme is denatured. So at a certain point in time, that enzyme can just completely shut down and stop working and never come back again. Lower temperatures tend to slow down that reaction rate, but higher temperatures can actually stop it. So that's the reason why if you get too scary of a temperature, you need to start really worrying about your proteins and how they're going to remain intact and that type of thing. Okay. Here's one of the more difficult concepts when it comes to enzymes. Reactions, if you start with a small amount of substrate and about an equal amount of enzyme, that reaction is going to take place really, really fast. So that's what I mean by where this starts, okay? Now let's start increasing the amount of the substrate concentration. So you keep the enzyme concentration the same, and you start increasing the substrate. And the reaction goes up, and it goes up, because the enzyme's saying, yeah, keep giving it, give me stuff so I can use it, I can use it, I can use it. But at a certain point in time, you just get so much substrate that it's like the substrate's waiting to get into the next enzyme to even work. And so the reaction rate levels out because the enzymes are working as hard as they possibly can. They can't go any faster. And so you see a constant in that reaction rate as the substrate concentration goes up. So initially, as you increase the reaction or the substrate concentration, the reaction rate will go up. But you can tell when you sort of max out that enzyme because it just simply can't go anymore. Okay. Now, your body has ways of controlling how much enzymatic action can take place. And it does that by inhibiting enzymes from working. There's two major types of inhibitors. The first being reversible, and the second is irreversible. Now, irreversible just shuts the whole thing down. So doesn't it make sense that your body doesn't want to have to remake enzymes very often? So it tends to use things that are reversible when possible. This is actually how a lot of drugs work as well. Okay, so an inhibition is basically a way to slow down the enzymatic activity by preventing enzymes from binding with substrates. So it's going to change the active site in some form. A competitive inhibition basically puts a molecule that is similar to the substrate in that active site so that when that molecule is there, whatever the substrate is can't get in. So it's not going to allow the substrate to go in there. Now this might work some In other words, like the enzyme might work a little bit, but it's going to be a reduced impact as how much that enzyme is working, because you have another molecule that's trying to get into that substrate trying to get into the active site of that enzyme. That's called competitive inhibition. In non-competitive inhibition, what happens is there's another molecule, let's say like this, right? That's inside. This was my competitive, so this fit here. It doesn't fit exactly, but it fits, right? So that's my competitive. It's not the same as the substrate. But in non-competitive inhibition, it's kind of like if a molecule binds over here and it changes the shape of that active site. See how that just changed by me adding something over here in this direction? It made that active site smaller. So with non-competitive inhibition, what can happen is it changes the active site by a molecule being on the other side of that enzyme. Therefore, the active site is changed and can't bind to the substrate anymore. So the difference in these two is that a competitive inhibition happens at the active site, and a non-competitive inhibition occurs away from the active site. Okay. Finally, we have irreversible inhibition. This happens when the enzyme is chemically or physically altered. The enzyme can no longer function. The whole enzyme is just no longer in work. And these happen quite often within your body. Ways to control how much of a particular substrate is changed. And it happens all the time. Thank you very much.